So this question is part A of question 3, and it asks you to find the maximum vertical distance from the water surface to the diver's shoulders. And the way you find this is by looking for when dy dt is equal to 0, as it is where the diver's at its maximum point, which is I'm showing right now, and it's at the point of the little arc where you have the relative maximum of the diver's path. And at that point, dy dt is 0, and then you set your equation equal to 0. So you set 3.6 minus 9.8t equals to 0. And you find that t at that point is equal to 0.36735. And you assign a letter to that value when you use it as a bound. So in this case, I am using b. So b would be equal to 0.36735. And now you would put this into the equation. Y of b equals 11.4 plus the integral from 0 to b of dy dt. And once you do this, so what you would do is you would put the equation 3.6 minus 9.8t into your calculator, and you would find the integral from 0 to b, and you would use that to find the integral. So once you do that, you would then add the value of that integral to 11.4, which should give you 12.061 meters. And that would be the maximum vertical distance from the water surface of the diver's shoulders. So part B asks to find A, which is the time that the diver's shoulders enter the water. And the way you find this is by asking you to find the time it takes from the starting point to the ending point, and this would give you the total distance essentially of the diver's path. And so you would use the equation y of a is equal to 11.4 plus the integral from 0 to a dy dt. And the reason you use dy dt in the integral is because dx dt isn't changing, and dy dt is the factor that's changing as the diver jumps up and comes back down. And once you find this, and once you do this, you integrate, and since a is unknown, when you integrate, a stays. So you would get 11.4 plus 3.6a minus 4.9a squared. And now that you have a variable of a inside this equation starts to look familiar, and it starts to look like a quadratic function. So you would set this equal to 0 and try to find a. And you can plug this into your calculator to find the roots of this quadratic or parabola. Once you plug into your calculator, and once you do that, you get a is equal to 1.936 seconds. And that would be your final answer. So part C of this question asks us to find the total distance traveled by the diver's shoulders from the time she leaps from the platform till the time she enters the water. So what we're doing here is looking at the time 0, which is when the diver's at the platform, and at time A, which is when the divers hits the water. And we found A in part C to be 1.936 seconds. So now we can put that into the equation to find arc length, which is the integral from 0 to a of radical dx dt squared plus dy dt squared dt. And now with the values that we already have, we can plug it into this equation. So the integral from 0 to a of radical 0.8 squared plus 3.6 minus 9.8t squared dt. And you find this by putting this into your calculator. And this gives you the total distance. So when you put this into your calculator, you get a total distance of 12.946 meters. And that would be your final answer. So what this means is that is the total distance that the diver travels from when she was at the platform to when she hit the water. So yes. So part D of this problem asks to find the angle theta between the path of the diver and the water at the instant at which the diver's shoulders enter the water. So as we know, the instant at which the diver's shoulders enter the water is at point A. So that means that at point A, we have to find dy dx. And in order to find dy dx, we have to plug in A into dy over dt over dx over dt. And once you do that, which is 3.6 minus 9.8 times 1.936 over 0.8. Once we do that, we get negative 19.219. And in this question, you see it as negative 19.216. I'm talking about the video. It's just a minor error that you can fix yourself. And once you have that, you can now go into finding the angle. So now in order to find, we can set up a triangle that has 19.219 as the opposite side and 1 as the adjacent side. And we do this because if you go back to algebra, when we talk about slope, we talk about rise over run. In this case, 19.219 would be the rise and 1 would be the run. And then you can write it as tan of theta is equal to 19.219 over 1, and that would translate to tan of theta equals 19.219. And in order to solve for theta, we would do the inverse tan of 19.219 equals to theta, and when you put that in your calculator, you get theta to be 1.519 radians.